We're looking at the section 3.2 review lesson. We're going to look at a sampling of problems from the first page. It says complete the table below to describe the qualities of proportional and non-proportional linear relationships. We'll focus on non-proportional. So non-proportional, for the table of values, the first important bullet point is that the y over x ratio is not constant. This was what we referred to as our COP. So we're saying there isn't going to be a COP for this relationship. For non-proportional linear relationships, though, the tables do have a change in y over change in x ratio is constant, or that is constant. And this was referred to as our ROC, our rate of change. So one isn't constant. That was our COP. We're kind of done with that now. And we're still going with ROCs, and this is going to stay constant. This is change in y over change in x. Other words that we used for ROC were M, rise over run, slope. All of these were the same. For a graph of a non-proportional linear relationship, it is linear but does not pass through the origin. And the equation comes in the form y equals mx plus b for a non-proportional linear relationship where we have an extra value at the end that's being added or subtracted. So these were the qualities of non-proportional linear relationships. And next we're going to go down and we're going to look at part of number 2. We're going to look at number 7, or the value of 7. And we're going to take 7 and we're going to plug it into this equation. So we have y equals 3 times 7. We're replacing x with 7 minus 8. We either do parentheses or a times dot, which is 21 minus 8, which means that the y value is 13. For table B, our equation is different, and we're plugging in different values here. And we're going to plug in 0. One-fourth times 0 is 0. And we're going to plug in 10. In order to multiply this, we're going to put this over 1. Both of these are divisible by 2. 4 divided by 2 is 2. And 10 divided by 2 is 5. And we multiply across to get 5 halves, or 2.5. Feel free to pause the video. Otherwise, we're going to go on to part C. Which of these tables represents a proportional equation? And it is table B, because the equation is in the form y equals mx. That is the deciding factor for something to be proportional or non-proportional. So A is non-proportional because it has this extra plus or minus value at the end. And B is proportional because it doesn't have anything being added or subtracted. Table B, because the equation is in the form y equals mx. And the last one we're going to look at is number 3. So we're looking for equations that come in the form y equals mx. For proportional, And then, although I'm not going to do that in this video, if we were looking for non-proportional, then we would be looking for y equals mx plus b. So as we hunt for answer choices on number 3, b, which actually was used in the previous problem, is proportional. A is proportional. D is not. It looks like y equals mx plus b. E is not. Looks like y equals mx plus b. C is not. And let's look at F before we cross this off. Let's actually distribute and see what happens here. 7 times x is 7x. 7 times negative 1 is negative 7 plus 7. And negative 7 plus 7 leaves us just y equals 7x. So actually this one is proportional. It didn't look like it initially. It was a trick question. So looking for a proportional equation, we're looking for equations that come in this form.